All right, so we're here with lesson 7. Um, this one was the particle simulator lab that we did in class where you had to come up with your own lab design. I think this one stumped a lot of people, probably because it was so open-ended. So hopefully talking about it here, if you missed it the first time or you need to make this up for some reason, um, hopefully it'll make it easier for you to understand. So first thing I want to point out is the solid to solid simulation right here is the one that we are going to be using. And before I show you that, I want to take a look at the worksheet. So you were supposed to come up with some sort of question about how energy is transferred between the two solids in this simulation. Um, there was a number of independent variables you could have picked from. I believe the four that you could have picked one from was changing the mass. One of them was changing the starting temperatures of the two individual masses. One was increasing the difference in temperature between the two masses. Um, and then the last one was how much contact the two masses have. And then you had to pick a responding variable, a dependent variable. Basically, what were you recording? And you had two options. It was either the energy transfer. By energy transfer, you're either looking for how fast this simulation reaches equilibrium or how much the temperature changed. Okay, so either how fast it happened or how much the temperature changed. It doesn't matter which one you pick. It doesn't matter which combination of independent and dependent variables, as long as you bring it all together to your investigative question. What is the effect of blank on blank? And it's your choosing. So for the procedure, you're going to set up the steps of what you are going to do. So what you're going to do is you're going to sorry about that. What you're going to do is you're going to write up your procedures. What are you going to do to test your question? The data table here, you do not need to use all of the data table. And in fact, I think we decided to cross off this total KE of particles and make it time. And you can fill out as much or as little of this. Remember, you're picking one independent variable. So like one thing's going to be changing this whole time. So most of the numbers that you write on a column, are going to be the same. Like, if say like you want to change the mass, you might have a mass of, let's say, 10 on the left, and it's going to be 10 all the way down because you want to stay consistent. And then maybe the right solid is the one that you're changing. So you can start with 10 and then 20 and then 30 and so on. So let's go back up here. It's really up to you. And you get to explore around and play around with it. Before I go ahead and show you the simulator, I want to make sure that you know this day 2 stuff. We did all of this in class. This is something you're going to have to copy. If I have the file uploaded on here, awesome. You can copy it off that. If I don't have the file uploaded on here yet, you'll have to come and ask me, and I'll let you take a picture of it, and I'll let you copy it. No big deal. So back to planning your original lab. You're going to be using this simulator. And a couple things that you need to know about the simulator. Up here is how fast or how slow you run it. I prefer to run it a little bit quicker just to save time. You can adjust the left solid. Here, actually, we need to say reset setup so you can actually see it. You can adjust the left solid's height. You can adjust its width, and you can adjust its starting temperature. Same thing for the right side. You can pick all of those. And then just to kind of note that the mass, however you decide to do it, if that's the one that you do, the mass is whatever the height times the width is. So if you're trying to, go up by tens, just keep that in mind that you'll have to, figure out what combinations, add 10 at a time. So the other thing that you're going to want to look at is the time here. And you're going to want to take a look at the temperature change of the left solid and the temperature change of the right solid and the temperature difference between the two solids. So let's say I move that solid down. I have to reset it for my changes to go into effect. And we run the simulation. And right there. So this is what we talk about when we say the temperatures are reaching equilibrium. Where do they even out at? Where is it so that the temperature is no longer changing because it's changed all it's needed to? And you can see what temperature that is that they met right here on the graph if you hover over any spot on the graph. And then you can actually pick that this value right here is how much time has passed. So this is 7.5 seconds. So I know that's a lot of information, and honestly, it's probably going to be easier for me to help you in person. And if you're really, really stuck, walk you through an investigation. But if you have any questions, if you really feel stuck, if that's something you want to do, just email me. We'll make it happen. And good job.